So for this problem, we have a new function known as setQ. And basically what setQ allows you to do is it assigns a value to a variable. Because we have two setQ functions, we therefore have two variables, CDS and OTH. So my first step would be to determine what these variables actually are. So from the first line, we get that CDS is equal to the list J, QK, parentheses, A. Then the second line gets a little bit more complicated. OTH is equal to cons 10 CDS. So, in order to get OTH, we need to add 10 to the existing CDS. This becomes 10 J QK A. The last line asks us to perform operations on OTH. So, just as I did in the last problem, I first like to split up OTH into its terms. The first is 10, then J, then QK, and finally A. I also like to number the functions that are acting on OTH. The first is CDR, the second again is CDR, then the third is car, and the fourth is reverse. So to keep myself organized, I've just rewritten the problem and replaced OTH with its actual list value. So the first step is CDR. Basically, we need to grab everything except for the first term, which is 10. So the resulting list is J, parentheses QK, A. We don't need the parentheses, but sometimes I keep it there just to keep myself organized. And once I finish a function, I always like to cross it off. The next step is also CDR. So it's taking everything except for the first term, which is now J. So what's left is QK and A. The third, cross it off. Now the third step is car. This takes the first value in the list. So that is parentheses QK. And last is reverse. This just reverses the list. So instead of QK, it becomes KQ. And now to do a final check, I make sure that the number of steps corresponds with the initial number of functions. As you can see, there are 4 functions in the beginning, and we have 4 steps.